Let's consider this problem that is the hydraulic cylinder C. Okay, extend and cause the collar A move to the left with a constant linear velocity of 8 foot per second as shown. Okay, we would like to find the angular velocity of log AB and velocity of point B when theta is equal to 30 degrees. So for this problem, actually we can use the relative motion analysis also, but for this case, maybe we will apply the absolute motion analysis instead of the relative motion analysis that we have done from the previous problem. Okay, so for this case, you see that we may have to set up the reference point. The reference point here, what it should be for this case, we may have to find out the reference point. It should be the point that should be has no motion for now. We may find for this case, we may draw the line first. That is, this line should be the reference line. Okay, and also for y-axis, this should be here. It should be the reference also. Okay, so according to this line, okay, the intersection is the reference point. We set up here as a reference point. We may define it to be point O now. Okay, and according to this, we may set up the axis here, that is X and Y. Okay, and when we do like this, so then it means that we measure point A according to the reference point. We measure to the right, okay, to the right. That is, we may define it to be SA. And to the right is a positive according to the positive sign mention that we set up. And same as B, we also have SB. That is upward as a positive. Okay. So according to this, after we set up the positive sign function already, okay, we may moving to define the geometry. Okay, define the geometry of each point that we consider. Okay, following the positive sign function that we set up. Okay, so for this case, SA is what? We know that is 2 right? SA should be 2 cosine theta. Okay, so according to this, we take the first derivative to this term that is become minus 2 sine theta. Okay, and then d theta by dt. That is equal to, okay, is equal to minus 2 okay, minus 2 sine theta d theta by dt is become omega, and now it is omega AB. Okay, and then for theta equal to 30 degrees. Okay, we know that V is equal to minus 8. Why it is minus 8? Because we set up SA to be point A to the right at a positive rate, but the problem gives us that is to the left. So then it is the negative one. Okay, so according to this, we can find out VA is equal to minus 8. And is equal to what? It is equal to minus 2 sine theta omega AB. Okay, after we solve this equation with theta equal to 30 degrees here, we can solve for omega. That's we obtain omega equal to 8 radian per second. Okay, and for SB now, okay, if we would like to find the velocity of point B also, okay, for this case, we would like to define between the velocity of point B. For velocity of point B, we know that this is reference. Okay, so then SB is equal to 2 sine theta. Okay, so we take the derivative to SB, that we get 2 cosine theta, same, it should be d theta by dt. That is become 2 cosine theta omega, okay, omega AB. Okay, and then it's become 2 cosine 30 degrees, right? And omega AB we already know that is equal to 8. Okay, it's equal to 8. 8 means that it's positive. So then it means that for this case, it should be clockwise. Okay, it should be clockwise. And omega AB is clockwise because we measure the angle. We measure the angular position. Okay, we define positive sign convention of linear and angular position S and theta with respect to the reference line and reference point. Okay, we measure from a fixed reference line the angular position theta of a line lying in the body. Okay, so for this case, so that is mean that if we consider theta is for this case it is a clockwise as a positive. Okay, you will see that for the absolute motion analysis, we have to imagine something that is not like the relative motion analysis. That is in my opinion, it's more straightforward because it follow the right hand rule and it follow the positive sign convention that we already set up with the consistency positive sign convention. But for this case, if we do the absolute motion analysis, for this case, we found out theta is clockwise as a positive one. So after here, we substitute each value into this. We obtain velocity of point B become 13.86 meter per second. That is complete this problem. Okay, and VB should be goes up. Okay, VB goes up because it is positive and it's consistent with the SB that is moving up as the positive one. Okay, and for this, okay, I will leave you to you may try to do this problem again by determining alpha AB. Okay, and acceleration at point B. Okay, if we set up acceleration of point A is equal to 0. Okay, for this case, you may find out the solution by yourself. Okay. So for this problem, do you have any question?